Alex Agrinian. I am co-founder and CEO of LeviSens. My background is in experimental physics, specifically precision metrology. Today, semiconductor manufacturers face a hard trade-off between speed and sensitivity. On the one side, there are optical methods, which are fast, but struggle to detect small defects and subsurface features, fundamentally limited by diffraction. On the other side, there are atomic force microscopes and scanning electron microscopes, which have a higher sensitivity, but are very slow, limited to tiny areas, often invasive to samples, and often requiring destructive sample preparation and vacuum operation. LeviSens' goal is to fill this gap. Our core innovation, the optolimited force microscope, is based on recent advancement in quantum optomechanics. Conventional force microscopes use microcantilevers, which are mechanically rigidly anchored. This mechanical anchoring introduces internal losses and fundamentally limits their sensitivity and speed. In our system, the probe is not attached to anything. Instead, it is levitated by a laser beam. This removes most of the background noise and improves sensitivity by up to 7 orders of magnitude. In our system, a small, about 100 nanometers sized silica sphere is brought close to the sample. By scanning the sample, we can map out the topography, subsurface defects, electrical and magnetic properties of the sample. The second key part of our innovation is an ultra-thin membrane, which physically separates the probe and the sample spaces without compromising the sensitivity of the instrument. In this way, the sample can be handled easily and rapidly, can be exchanged rapidly in air, while the probe is subject to ultra-high vacuum, where it can reach its highest sensitivity and resolution.
I'm Andy Geraci, professor of physics here at Northwestern University and co-founder of LeviSens. In our lab, we've invented, patented, and experimentally demonstrated a new method for measuring surface forces that's 10 million times more sensitive than an atomic force microscope. While we originally did this for fundamental physics research, we believe this technology could potentially revolutionize semiconductor surface metrology, opening doors to future advanced electronics. And N.XT support would help us develop a prototype instrument, validate it with early users, and then turn this scientific breakthrough into a real practical commercial instrument. Thanks for your consideration.